Category 4, STAAR review, quadratic functions and equations, everything about parabolas. We start with number 1. We're looking for the zeros of this function. So we've got an equation. I know I can graph this equation and find the zeros, the x-intercepts. That would be one way. The other way to know is to know that these factors are the opposite signs of the solutions. So when we solve, find solutions or zeros or all that, remember that's when we say that 2/3 times x plus 6 times x minus 9 equals 0. If all of these things multiply together to equal 0, then one of these things has to be 0. If x plus 6 is 0, then x has to be -6. If x minus 9 is 0, then x has to be +9. The signs are opposite. So I know my answer is -6 and 9, which is B. Other way to do that, though, like I said earlier, probably the easier way, go graph this equation just like it is. You don't have to FOIL, you don't have to distribute. You can type that in exactly like it is in the calculator. 2/3 times x plus 6 times x minus 9. It's going to give you a parabola with these two roots, or zeros, or x-intercepts. Number 2, the graph of the equation x squared minus 3 is translated up 4 units. What will be the equation of the new graph? Well, I know that x squared minus 3 is shifted down 3. Looks like this. If I shift it up 4, or translate it up 4, 1, 2, 3, 4, that's where the new vertex or y-intercept would be. So that is up 1, that's going to be x squared plus 1, which is A. Again, second option, calculator option. There's always the calculator way to do these. Go graph each one of these parabolas. See what they look like. One of them is going to very clearly be the exact same graph, shifted up 4, the others won't. So A is going to be our answer there. Number 3, we have a graph here. They're wanting to change, or they're asking how it's changed if the constant 4 is added to the function. You got to remember what a constant is. Y equals ax squared plus c. We have a coefficient, is that, multiplied to the variable. The variable is x, and the constant is a number without a variable. So if we take this equation and add a constant of 4, then we're getting x squared plus 4. If we added a coefficient of 4, that would be 4x squared. We're not doing that. We're adding a constant of 4, so it's the plus 4 at the end. You can graph that in your calculator, or you can just know that when you add in a plus c, that shifts it up 4 units. So it's not going to be wider or narrower or translated down. It's going to be translated up. Number 4, the solution set for the equation 3x times parentheses 9x plus 10 equals 8. A couple things going on here. One, I don't like the form that this is in. I don't like how that looks. I'm going to distribute to make it look like the standard form that we're used to seeing, ax squared plus bx plus c. So 3x times 9x is 27x squared. 3x times 10 is 30x equals 8. Now I can solve this equation. Well, before I solve it, I got to make it equal 0. We always have to have our equations equal to 0. So minus 8, that gives me 0. This is not a like term with anything else on there, so it just goes at the end. 27x squared plus 30x minus 8. This is what I am solving. We can use quadratic formula, we can use Xbox, or we can graph. I'm going to graph. I think graphing is always the easiest, unless it's very simple, common numbers that you can easily Xbox with. this is going to be graphing. So 27x squared plus 30x minus 8. I'll go look at my calculator. New document. Graph 27x squared plus 30x minus 8. Do not type in equals 0. Don't do a relation. We're graphing the equation, and we're going to find where it equals 0. So you don't type in the 0 equals part. We're just graphing y equals all of that. We get our parabola. I have two zeros right here. Menu. I'm going to analyze graph number 6. Find the zeros. And I have 0.222. Menu 6, 1. And I have negative 1.33. Right? Yes. So negative 1.33 and 0.222. Negative 1.33 and 0.222. These are decimal versions. The answer gives me fraction versions. I need to convert. It's very difficult to convert decimals into fractions, so I'm not going to worry about that. Instead, I'm going to convert these fractions into decimals. Starting with answer choice A, negative 4/3. When I go to my calculator, new page, calculator, negative 4/3, Control Enter, changed it to a decimal. That's negative 1.33. That was looking good. I then have, I think it was 2/9. Control Enter, 0.222. That looks like answer choice A is it. Just to be safe, you should probably go check the rest of them, but you'll quickly find out they do not match what our solutions were on the calculator. So, a lot of parts going on with that question. You had to do a lot of different work. You had to FOIL, you had to graph, you had to find these, you had to convert these decimals, but it's what it takes sometimes. We got A is our answer there. What, number 5? Oh, there we go. Let's scroll up far now. Number 5, we're looking for the vertex of this graph. Only way to find the vertex is to go graph it. Negative x squared plus 2x plus 3. Negative 2x squared plus, messing all up. Negative x squared plus 2x minus plus 3. There's our graph. I can pretty much see it just looking at it. It's over 1, up 4. So 1, 4. But just to make sure, I'm going to go menu. I'm going to trace. I'm going to graph trace. And I'm going to arrow to the right until I get at the maximum, which is 1, 4. Go back to here. We got 1, 4. C. Number 6. Which of the following polynomial equations best represents this graph? They give us a graph, they give us equations to choose from. This is a calculator question. I'm going to graph each one of these one at a time, see which one matches. So, something to point out that I notice here as I'm looking, they're counting by 2s, not by 1s, so be careful there. Gotta make sure you look at the scale. I'm looking for a parabola with the roots of negative 5 and 2. So, I'm going to check A, parentheses x plus 5, parentheses x minus 2. So let's go see what we have. Parentheses x plus 5, x minus 2. If I graph that, I do have the zeros at 2 and -5. That one's looking like it might be it. Just to make sure, I'm going to go check all the rest of them. Or I could go check where the vertex is also. If I find the vertex, I'm going to analyze this time to find the vertex, which is the minimum. It's somewhere between here and here. And it's -1.5 and down 12. So look at my graph here. That's about -1.5 and down about 12. That is my right answer. I'm going to go check B, C, and D in the calculator just to make sure that they don't also match that, because I might have messed up. There might be a couple that look very similar. When we go graph B, C, and D, they're going to be significantly different. So double check them just to make sure. 7. What happens to the minimum value of this graph, 5x squared plus 4? I'm going to pause and go graph that really quick. All right, here we have 5x squared plus 4. They want to know what happens to the minimum. Well, the minimum is right here. What happens to that when the coefficient becomes -5? So my coefficient right now is a +5. If I change that coefficient to a -5, x squared plus 4, then my new graph looks like this. The minimum of the first graph switches to be the maximum of the second graph. So if I look at my answer choices, the minimum value does not become 5 less. It doesn't move. The minimum value is not 10 less. The graphs have the same minimum. Well, they are the same point, but the minimum, since the parabola flips, it's actually the maximum now. So J is looking good. The minimum value of the first graph becomes the maximum value of the second graph. There's our answer. Number 40. We're going to call this one number 8. Something happened. What are the solutions to the equation y equals x squared plus 2x minus 15? Solutions are also known as roots, zeros, x-intercepts. We can graph it and find the roots or the x-intercepts. This one looks to be pretty easy to factor because it's the easy type. So that's what I'm going to do. -15 up top, 2 on bottom. We have 5 times -3 gives us -15. 5 plus -3 gives us 2. So x plus 5 times x minus 3 is 0. To go from factors to solutions, we have to think this or this has to be 0. Well, if x plus 5 is 0, then we know x has to be, x has to equal -5. If x minus 3 is 0, then x has to equal +3. So our solutions, -5 and +3, G. You can graph that, or you can use quadratic formula also. Number 9, not 94. Number 9, we have a graph of x squared plus 6x minus 7 is shown. What is the axis of symmetry? Axis of symmetry is one of our note cards. The vertical line straight through the center of the parabola, or through the vertex of the parabola. It folds the parabola in half. The equation of that line is always going to be x equals something. So it's not B, it's not A. We got to look at how far over the line is shifted. If I look at my axis, it is over -3, so x equals -3. If there was any confusion at all with this, go to your calculator and graph these equations. If you graph x equals -3, it's going to make this exact line right here. If you graph y equals -3, it's going to make a horizontal line. We know that's not it. So, if your calculator can help you and you need the help, use your calculator. Last question, number 10. What is the range of the function x squared minus 3? I need to know what this looks like. I know that x squared minus 3 is my parent function shifted down 3 units. So I'm going to take the parent function, the normal parabola, shift it down 3 units. Our calculator can definitely graph that for us too if we need it to. Range is bottom to top. Range is also the y value, so I know it's not f and it's not h. So, are my y values greater than or equal to -3, or are they greater than or equal to 0? Well, look at your boundary of this parabola. Where's the bottom boundary? It's at -3. So all the y values are above -3. It's going to be G. That is category 4. One more. Category 5 left. Good luck.